Thanks, Elena. So I will present you an alternative approach to collaboratively building user-extensible interactive systems that combines literate computing with the possibilities of Webstrates and what we call Codestrates. So the work presented today was a joint effort together with my colleagues Midas Nouwens, Kristian Antonsen and Clemens Klokmose, all from Aarhus University in Denmark, and James Eagan from Telecom Paris Tech in France. I am Roman, also from Aarhus University. 2 years ago at UIST, Klokmose et al. Presented a vision of software with 3 principles. The first one was shareability, where the content of documents can be easily shared with others, and changes to a shared document are actually reflected in real time. Distributability is achieved by building on web technologies where documents can be opened in the browser, including devices such as laptops, tablets, and smartphones. And the third one was malleability, which allows users to collaboratively edit documents and add content and also application code. In their talk, they also presented Webstrates as one instantiation of that vision. And Webstrates demonstrates how software can become reprogrammable and extensible in a collaborative fashion, basically blurring the distinction between applications and documents through a simple change to the web stack. So what they did is they made the document object model of web pages persistent and collaboratively editable. So here you can see an example of a Webstrate, which is open in 2 browsers, one to the left and one to the right, which shows the distributability. And simply speaking, a Webstrate is a web page where changes made to the DOM in one browser are persisted on the server and sent to all clients that have the same Webstrate open. And this allows for shareability across the different users. And malleability, as supported in Webstrates, actually happens in 2 ways. And as you can see, one here is the first one is the web browsers built in developer tools to directly change and edit the DOM of the page. And the second one they present is demonstrated in this video is through a Webstrate that has the functionality of a code editor, which is on the top left, where the user can load the DOM of another Webstrate through transclusion and indirectly edit the DOM, for example, CSS in this case of the video. So in both of these cases, there is a separation between using a Webstrate and changing its appearance and behavior. So the first approach with the developer tools kind of limits the development to desktop computers and makes use of a tool that was actually meant for debugging rather than developing. And the second one introduces an application document relationship between one Webstrate where the user has the overhead of loading the target Webstrate in another one and to actually make changes to the code. So this maintains a separation between developing and using an interactive system that is actually prevalent in most nowadays software. So what we wanted to do in this project is to explore a closer connection between the two, where using and developing actually becomes or can become part of the same activity. So what we did is we looked at other approaches and systems that already narrowed this gap between developing and using. And the first one, as you might know, is code playgrounds. In this case, it's CodePen, that lets you program and execute code while the results of the computation are immediately reflected in the same environment. However, as you can see in the video, the application state of a playground is not persisted and reset after page reload, which actually doesn't allow to use them beyond being a playground. And when you share a playground like CodePen or JSFiddle, you actually share the code, but you do not share the state of the program. The second approach that are interactive notebooks, as in Jupyter Notebook, to write prose and code in the same document. And as you can see in the video, it's an interactive notebook document that has blocks of code and text. And it allows to do live computation within the document, for example, for statistical analysis or to generate visualizations. However, in real-time collaboration is not really a fundamental part of interactive notebooks architecture, and actually sharing and collaborating or collaboratively editing an interactive notebook requires external tools, for example, version control systems like GitHub. And developing applications within a notebook also requires a sophisticated understanding of the notebook's system architecture. But interactive notebooks, they have been recently seen adoption among non-professional programmers, especially in the fields as diverse as data science, journalism, or computing education. And Fernando Perez, who is a co-creator of the Jupyter notebook, he calls this interactive notebooks approach to computing actually literate computing. And he describes it as the act of weaving a narrative directly into live computation, interleaving text with code and results to construct a complete piece that relies equally on the textual explanations and the computational components. So what it does, it treats code just as another way of expressing yourself, which is similar to text or images or videos. So we believe that using a literate computing approach is one way to narrow the gap between developing and using interactive systems. By supporting this way of mixing code and prose, we can support programming of applications in the same environment as using the applications. So what we present, and we'll see later a demo, an alternative approach to collaboratively building user-extensible interactive systems that combines literate computing with the possibilities of Webstrates. And the first one, Codestrates, pushes literate computing approach further, as found in interactive notebooks, by allowing collaborative computation, extension, and development of applications within the same environment. And it hereby narrows the gap between collaborative development and use. Second, Codestrates enables prototyping in a manner which is similar to playgrounds, but with the potential for playgrounds to become usable applications by persisting the application state. And the third one, Codestrates provides a development environment for Webstrates that actually goes beyond the paradigmatic application document model, as you've seen before. So like Webstrates, or like with Webstrates, a Codestrate is essentially a web page, but whose content, presentation, and behavior can be edited within the page, and whose edits are inherently made persistent. So let me demonstrate that for you. So this is a Codestrate transcluded on the slide. And it builds on the concept of literate computing, where we have sections, as for example here. And a Codestrate also can have paragraphs, and we have types paragraphs of body paragraph, style paragraph, code paragraph, and data paragraphs. And body paragraphs is what's usually considered the content of a web page, which can be edited through rich text editing capabilities. Like this. But it also can be edited through an HTML inspector, where you can edit simply JavaScript. A style paragraph is simply to style the contents of the document. So I can give this one an ID demo, and from then on I can refer to it as ID demo. Set the background color. Background color to white, and the foreground color to black. And code paragraphs are simply JavaScript paragraphs where you can enter code. For example, alert. And these paragraphs can be either executed on page load by setting this little green man to run on load. So whenever the page in Codestrate loads, it executes the code. Or it can be triggered by pressing the play button right there. So I already created another example, which is a groceries list, by opening the global menu to the left. And there is also multiple sections that are actually right now hidden. I can reveal the section, for example, the groceries list. The groceries list contains a body paragraph, which contains a headline, an input element, and also an unordered list. And two style paragraphs, which style the body paragraph, the UI of the groceries list. And it contains a JavaScript which adds an event listener whenever the enter key is pressed. It takes the content of the input element and adds the value of that as a list item to the unordered list. Let me demonstrate. So I want milk. Now what you can do is with Codestrates, you can put paragraphs, body paragraphs, into full screen mode by long press on the full screen button. And by this you make the actual application a real application. And you can open it on, for example, another device. As you can see here, it's running on a smartphone. And I can use it the same way as used in the laptop. And I really like ice cream. So I can add items from different devices, which is kind of the shareability and the distributability. And of course, it's fully interactive by crossing off the items of the list. But Codestrates has many uses beyond just being groceries lists. So for example, ranging from formerly mentioned interactive notebooking to game and application development. For example, in this presentation I'm using right now, it's written in a Codestrate, but with the capabilities of having presenter tools. It has also been used by Midas for his presentation at KAI in 2017, which he had to give remotely because due to visa issues. We used it for our own classes, for example, to teach non-computer science students programming, specifically HTML5, JavaScript, and CSS. And there a student is writing a function, a for loop, which changes the pixels of an image to be a sepia filter. And last, we also used it in a different course to teach students physical computing, where the students connected an Arduino Uno board and programmed the interaction interactively. We also hired a professional game developer who developed in the course of a day a tank game which he had developed before, but he got a little introduction to Codestrates, but from then on he was actually able to develop a fully functional multiplayer game. And I can roam around with the arrow keys and I can shoot with the spacebar. And as you can see, there's a misfunction in the application. Basically, the bullets don't bounce off the walls. But I can now go down and find the error, and I can actually comment the piece of code in line 20. And then if without rerunning the code, I'm just roaming around and shooting again, I'm basically, bullets now bounce off the walls. I can change interactively the behavior of the application. So let me explain how a Codestrate works. So code execution in Codestrates differs from the regular JavaScript execution routine in the browser. Its execution relies on three integral components. The first one is there's a bootstrap code in a script element in the document head, as shown in the bottom of the slide. And all other code is stored in pre-elements, which is actually preventing it from being executed on page load. But then there's a third one, a paragraph with the ID bootstrap, which you can see right there on the right side, which is code in the pre-element, which is executed by the single line of code at the bottom, which then bootstrap the rest of the Codestrate. Now, in this example, you can see an actual Codestrate building slowly up after it has been loaded, and it's artificially slowed down by 2 seconds every step. And the execution of the code paragraph with the ID bootstrap, which queries the DOM for all other code paragraphs with the attribute run and load, and synchronously executes them in the order as they appear in the DOM. And then, for example, in this one, the section and the paragraph user interfaces and the code mirror user interface are generated on the fly. So usually a browser executes a script on page load synchronously, but as soon as the page has loaded, they are executed asynchronously. And that makes it very difficult to execute code that depends on pre-execution of other code, for example, if you require jQuery. And then Codestrate actually makes sure that the execution of code is, again, synchronously allowing for code dependencies. I think I have quick time for another demo. So apart from using Codestrates just as building applications, we can also use them to extend them, or the functionality in itself. So in this example, there's Bob's laptop, and Bob wanted to add support for remote cursors because he often collaborates with his colleagues. And he implemented a remote cursor extension to Codestrate, which now shows, for example, the cursor position. So if I move my finger on my tablet, which also has the same Codestrate open, I can see the remote cursor. And then in order for him to use it later on, he can mark the section as a system section by toggling the puzzle piece. But also, Bob talks to Alice and he tells her about his extension. And she was very eager also to use that extension for her work because she also often collaborates with her colleagues. So Bob sends Alice the ID of this Codestrate with his extension. which she now can open, for example, in one of her Codestrates, and then pull the system sections into this Codestrate, which now transcludes Bob's Codestrate with the extension and replaces the system sections of Alice's Codestrate. And after reload, Alice will be able to use the same extension as Bob has used before. So if I move now my finger again on the screen, now Alice also has the extension to share remote cursors. Our current implementation of Codestrates also has limitations. So the execution, for example, as presented in the paper, is only limited to JavaScript execution because it is using the browser's JavaScript runtime. But we are also actively working on other ways of out-of-browser execution, for example, supporting Node.js, similar to interactive notebooks or Jupyter Notebook, also, and Python, of course. And then pulling system sections, as you've seen before, it's from another Codestrate, completely replaces the system sections of a Codestrate. But we also want to experiment with diffie mechanisms known from, for example, version control systems. Making a Codestrate editable, of course, adds additional code and external libraries that has to be loaded. For example, Code Mirror Editor, which adds like 800 kilobyte of code. And, of course, additional computation to actually spin it off. We have already started to experiment with lazy loading mechanism where the editor capabilities are loaded after the Codestrate has been loaded. And then last, programming in Codestrates right now is very textual. And if you want to support a broader audience, we want to broaden it up and bring in alternative entry points for users to express computation in very, very different ways. For example, Scratch-like block-based interfaces. There's one more slide. Codestrates combines real-time collaboration and complete reprogrammability, and it treats code just as another medium of expression on the same level as text and images. And this allows for a type of interactive systems that develops organically. It subverts from the traditional application document model of interactive systems, and it has been very powerful and a flexible tool for us, allowing for ad hoc extension of functionality. So in our experience, extending or developing the Codestrate isn't really a separate activity. Functionality is added in response to the current tasks at hand that we have. For example, in the process of creating this presentation, I added text-to-speech to read out my speaker notes to see how long my presentation is going to be. I added transcoding other Codestrates into the slide to interactively demo them on the slides without actually switching between applications or alt-tabbing between them. And also, we have been using it for the past year now for our own teaching, research projects, and prototypes, and conference presentation and PhD defenses. And I promise this is going to be the very, very last slide. It may take a while. Depends on the internet connection. It's working, yeah, sure.
So anyone would like to run to the microphone? Please do that now.
So this, just quickly, this is a Codestrate also transcoded on a slide, and it actually is the actual codestrates.org website. And what I just did, I exited the full screen of a body paragraph, which contained just a template text, and I will now full screen another body paragraph, which contains the description of Codestrates, the conference paper, and the video. It also contains links to examples and also a link to create a Codestrate. And it's now available for all of you to play and tinker around with it. The URL is codestrates.org. You are free to start using it for your own projects. You're welcome to contact us for research directions and also for collaborations. Thank you.
Rendering that you interact with on the web. Since you have have both the code and the rendering, and it's all part of the same organic document, to really facilitate people working together, have you built in any, you said, oh, I saw the bug and I commented it out and there it works now, it bounced the bug. That's easier said than done. So do you have any support for learning about the code that other people have written in this collaborative environment?
That's definitely a good question, Elena. We have thought about it, but we have not. It's not yet part of a Codestrate. It's just an initial seed for us. But if you guys are like to collaborate and go further research directions, we would like to collaborate on this, integrating possibilities to analyze the code that people write, maybe finding mistakes they make earlier, or also what Alok presented earlier, integrating possibilities to, for example, create tutorials within a Codestrate, and then people can interactively use and manipulate within the document.